Introduction. Before starting with the concept of variation, let us revise what we have learned in our earlier class about ratio and proportion. Ratio. When we compare two quantities by division, that is, by dividing one with the other, it is called as ratio. Proportion. If after comparison two ratios are equal, they are said to form a proportion. That means four numbers P, Q, R and S are in proportion if P is to Q is same as R is to S, that is, P is to Q is equal to R is to S, or P upon Q is equal to R upon S. The product of their means is equal to the product of the extremes. Direct variation. Two quantities are said to be in direct variation if the increase or decrease in one quantity leads to the increase or decrease in the other quantity in such a way that their ratio always remains constant. We say that one variable varies directly as the other. Constant of variation. The symbol used to denote variation is proportional. When A and B vary directly with each other, we can express this fact in mathematical language as A is directly proportional to B. If K is the constant of variation, then A upon B is equal to K, or A is equal to KB. Example 1. Given x is proportionate to y, and when x is equal to 15, y is equal to 3, find 1. Y when x is equals to 35, and second, x when y is equal to 4. Solution. If x is proportional to y means x upon y is equal to k, where k is the constant of variation. This implies that x is equal to ky. When x is equal to 15 and y is equal to 3, this means 15 is equal to k3 or k is equal to 5. 1. Using this value of k, we have x is equal to 5y. So when x is equal to 35, it implies 35 is equal to 5y or y is equal to 7. 2. When y is equal to 4, x is equal to ky. This implies x is equal to 5 into 4 or x is equal to 20. Relation between direct variation and proportion. Example 1. Rashmi has a road map with a scale of 1 centimeter representing 18 kilometers. She drives on a road for 72 kilometers. What would be her distance covered in the map? NCERT. Solution. Distance on map and actual distance are directly proportional. Distance on map, actual distance, 1 centimeter, 18 kilometer, x centimeter, 72 kilometers. This implies 1 is to x is equal to 18 is to 72, or 1 is to x is equal to 1 is to 4, or x is equal to 4 centimeters. Example 2. A laborer earns rupees 141.75 in 26 weeks. How much money will he earn in an year? Solution. Since earning increases or decreases in proportion to the number of weeks, therefore, the two quantities vary directly. We know that income 1 is to income 2 is equal to number of weeks 1 is to number of weeks 2. So, 141.75 is to X is equal to 26 is to 52, as 1 year is equal to 52 weeks. This implies that 141.75 into 52 is equal to X into 26, or X is equal to 141.75 into 52 upon 26 is equal to 141.75 into 2, so X is equal to rupees 283.50. Thus, he earns rupees 283.50 in a year. Example 3. A machine produces 180 tools in 6 hours. How many tools will it produce in 9 hours? Solution. Let X be the number of tools and Y be the number of hours. From the question, Y is proportionate to X, or Y is equal to Kx, where K is the constant of variation. When number of tools is 180 and number of hours is 6, then 6 is equal to K 180, or K is equal to 6 upon 180 is equal to 1 upon 30. Thus, Y is equal to 1 upon 30 into X. We find the value of X when Y is equal to 9 hours. This implies that 9 is equal to 1 upon 30 into X, or X is equal to 270. Thus, number of tools produced in 9 hours is 270. Inverse variation. When one quantity increases, the other decreases proportionately, and when one quantity decreases, the other increases proportionately. This kind of variation between two quantities is known as inverse variation. We say that the two quantities vary inversely. Constant of variation. This product is the constant of variation for the inverse variation. That's why when X and Y vary inversely, we write X is proportional to 1 upon Y, or X is equal to K upon Y. Then XY is equal to K is equal to constant, and K is positive. Inverse variation and proportion. If x1 and x2 are two different values of x, and y1 and y2 be the corresponding values of y, then x1 y1 is equal to x2 y2. This implies x1 upon x2 is equal to y2 upon y1. This result is useful in solving inverse variation problems. Also, x1 upon x2 is equal to y2 upon y1 implies that x1 is to x2 is equal to y2 is to y1, or x1, x2, y2 and y1 are in proportion. Example 1. Given that x varies inversely as y, and when x is equal to 5, y is equal to 50. Find 1. Y when x is equal to 2, and 2. X when y is equal to 10. Solution. Since x and y vary inversely, this implies x is proportional to 1 upon y, or x is equal to k upon y, or xy is equal to k, where k is a constant of variation. This implies when x is equal to 5, y is equal to 50, or 5 into 50 is equal to k, or K is equal to 250. Thus, xy is equal to 250. 1. When x is equal to 2, then 2y is equal to 250. Or y is equal to 250 upon 2 is equal to 125. 2. When y is equal to 10, then x into 10 is equal to 250, or x is equal to 250 upon 10 is equal to 25. Thus, for x is equal to 2, y is equal to 125, and for y is equal to 10, x is equal to 25. Example 2. A car takes 2 hours to reach a destination by traveling at the speed of 60 km per hour. How long will it take when the car travels at the speed of 80 km per hour? Solution. Speed and time taken are inversely proportional. Since more the speed, less is the time taken. Speed, time taken. 60 km per hour, 2 hours. 80 km per hour, x. 60 upon 80 is equal to x upon 2, or 60 into 2 upon 80 is equal to x. So x is equal to 1.5 hours. Example 3. A farmer has enough food to feed 20 animals in his cattle for 6 days. How long would the food last if there were 10 more animals in his cattle? NCERT. Solution. The more the number of animals, food will last for less number of days. So number of animals and number of days are inversely proportional. Number of animals 20, number of days 6. Number of animals 30, number of days x. So 20 upon 30 is equal to x upon 6. This implies 20 into 6 upon 30 is equal to x. That is, x is equal to 4 days. Introduction. In the previous chapter, we have already seen that 1. If the rate of work is constant, then the time varies directly as the work. 2. But for a given amount of work, the time taken varies inversely as the number of workers. Thus, problems on time and work are an application of direct and inverse variation. Before taking up problems, let us revise some rules. A. Suppose A can finish a piece of work in n days. Then work done by A in 1 day is equal to 1 upon nth part of the work, unitary method. B. Suppose that work done by A in 1 day is equal to 1 upon nth part, then time taken by A to finish the whole work is equal to n days. Example 1. If 28 men can do a piece of work in 65 days, how many men will do it in 35 days? Solution. If x denotes the number of men and y denotes the number of days, then x vary inversely as y. So, xy is equal to k constant. When x is equal to 28 and y is equal to 65, implies 28 into 65 is equal to k, or k is equal to 1820. When y is equal to 35, then x into 35 is equal to 1820, or x is equal to 1820 upon 35 is equal to 52. Thus, 52 men can finish it in 35 days. Example 2. Avisha and Neha together can paint a wall in 8 days. Avisha alone can paint the wall in 12 days. How long will Neha take to paint the wall herself alone? Solution. Avisha plus Neha can paint a wall in 8 days. So, Avisha plus Neha's 1 day's work is equal to 1/8 part of the wall. Avisha alone can paint the wall in 12 days. Avisha's 1 day's work is equal to 1/12th part. Therefore, Neha's 1 day's work is equal to Avisha plus Neha's 1 day's work minus Avisha's 1 day's work. This is equal to 1 upon 8 minus 1 upon 12. This is equal to 3 minus 2 upon 24 is equal to 1 upon 24. Implies that Neha alone can do the same work in 24 days. Example 3. A can build a room in 50 days. A and B together can build a room in 25 days. They work together for 15 days and then B goes away. In how many days will A finish the remaining work? Solution. Time taken by A to finish the work is 50 days. A's 1 day's work is equal to 1 upon 50th of work. Together, A plus B can finish the work in 25 days. So, A plus B's 1 day's work is equal to 1 upon 25th part of work. A and B work together for 15 days. So, A plus B's 15 days work is equal to 15 into 1 upon 25 is equal to 3 upon 5. Remaining work is equal to 1 minus 3 upon 5 is equal to 2 upon 5. Now, 1 upon 50th of work is done by A in 1 day. Therefore, 2 upon 5 of work will be done by A in the brackets, 2 upon 5 into 50 days. Hence, the remaining work is done by A in 20 days. Example 4. A, B and C can do a piece of work in 8 days, 12 days and 15 days respectively. How long will they take to finish if they work together? Solution. A can do a piece of work in 8 days. A's 1 day's work is equal to 1/8 of the work. B can do a piece of work in 12 days. So B's 1 day's work is equal to 1/12 of work. C can do a piece of work in 15 days. So C's 1 day's work is equal to 1 upon 15th of work. Therefore, A plus B plus C's 1 day's work is equal to 1 upon 8 plus 1 upon 12 plus 1 upon 15 is equal to 15 plus 10 plus 8 upon 120. This is equal to 33 upon 120. A, B, C together can finish the work in 120 upon 33. This is equal to 40 upon 11. This is equal to 3 and 7 upon 11 days. Example 5. Pipe A can fill a tank in 3 hours. Pipe B can fill it in 4 hours. And outlet C can empty the full tank in 6 hours. If all 3 pipes are kept open simultaneously, in how many hours will the tank be half full? Solution. Pipe A can fill a tank in 3 hours. Therefore, in 1 hour, pipe A can fill 1/3 of the tank. Pipe B can fill it in 4 hours. Therefore, in 1 hour, B can fill 1/4 of the tank. Pipe A plus B can together fill is equal to 1 upon 3 plus 1 upon 4 is equal to 4 plus 3 upon 12. This is equal to 7 upon 12 of the tank. Now pipe C can empty the tank in 6 hours. Therefore, in 1 hour, pipe C can empty 1/6 of the tank. Therefore, net result of the pipe A, B and C in 1 hour fill is equal to 7 upon 12 minus 1 upon 6. This is equal to 7 minus 2 upon 12 is equal to 5 upon 12 of the tank. Therefore, pipe A, B and C together take 12 upon 5 is equal to 2 and 2 upon 5 hours to fill up the tank, and tank will be half full in 1 upon 2 into 12 upon 5 hours. This is equal to 6 upon 5. That is equal to 1 and 1/5 hours. Time and distance problems, special cases. Example 1. A train 300 meter long is running at a speed of 60 kilometers per hour. How long will it take to cross a tree? Solution. When a train has to cross a stationary object whose length is negligible, example tree, pole, etc., it has to cover a distance equal to its own length. See the figure given. Therefore, in this case, distance covered is equal to 300 meters. This is equal to 300 upon 1000 kilometers. This is equal to 3 upon 10 kilometers. Speed of train is equal to 60 kilometers per hour. Time is equal to d upon s is equal to 3 upon 10 upon 60 is equal to 3 upon 10 into 60 hour is equal to 3 upon 10 into 60 into 60 minutes is equal to 3 upon 10 minutes. This is equal to 3 upon 10 into 60 seconds, and that is equal to 18 seconds. Example 2. The speed of a train 150 meters long is 50 kilometers per hour. How much time will it take to pass a platform 750 meters long? Solution. When a train has to cross a stationary object with some length of its own, example platform in this case or a stationary train, then the distance which moving train has to cover is equal to the sum of the lengths of the stationary object and the train itself. See the figure given below. Distance to be covered is equal to 750 meters plus 150 meters equals to 900 meters. Distance covered is equal to 900 meters is equal to 900 upon 1000 kilometer. Speed is equal to 50 kilometers per hour. Time is equal to d upon s is equal to 900 upon 50 into 1000 is equal to 9 upon 500 hours. This is equal to 9 upon 500 into 3600 seconds is equal to 36 into 9 upon 5 seconds, and that is equal to 64.8 seconds.